Welcome everyone. We are discussing vectors. Today we also discuss only the basic problems of board. So before we start, we recapitulate the basic formulae. So number one, if P x y z be position of a point in space, then its position vector can always be represented by r vector equals to xi cap, yj cap, zk cap. So where we know ijk are unit vector along coordinate axis. So if it is given or not, I cap is unit vector along x axis, j cap is along y axis, and z cap is k cap is along z axis. So P x y z be position of a point in space, then r equals to this. Now mod r equals to x square y square plus z square. So this is mod r. And here xi cap, yj cap, zk cap are components, are vector components of r along axis, and x, y, z are scalar component. All of you know it. Now r cap is unit vector. It is defined r vector by magnitude of r. So position vector of a point. Then second one, number 2. If A x1 y1 z1 and B x2 y2 z2 are 2 points in space, then AB vector equals to PV of B minus PV of A. So this is x2 minus x1 into I cap, y2 minus y1 into j cap, and z2 minus z1 into k cap. So this one, all of you know it. Number 3, so if two vectors A and B are parallel or collinear, then one can be expressed as a scalar multiplication of other. Lambda is scalar. So we use number 1, this is result, number 2, number 3. And look, number 4, if xi equals to yj equals to zk equals to ui plus vj plus wk. That is, if two vectors are equal, then x equals to u, y equals to v, z equals to w. So, these are our working tools. So, today we will confine our attention to basic problems, that is board's problem. Now, I consider some problems of unit vector. So, there are 1 or 2 marks problem for board exam. So, look, number 1. Find unit vector in the direction of P towards Q. In the direction of P towards Q. So, P and Q are 2 points, 1, 2, 3, and Q is 4, 5, 6. So, P to Q. So, arrow will be in this direction. So, ijk are unit vector. In all cases, if it is point in 3 dimension, then we write let ijk are unit vector along axis. Along x-axis is I, then j, then k. It is given or not. Then what is PQ? PQ is PV of Q, point Q, PV of P. So, 4I plus 5j plus 6k minus I plus 2j plus 3k. Difference of this PV. So, 3I plus 3j plus 3k. 3I plus 3j plus 3k. Now, this is PQ vector. So, we need mod PQ cap. So, this equals to PQ by mod of PQ, magnitude of PQ. So, 3I plus 3j plus 3k. So, this is PQ vector. And what is the magnitude? 3 square plus 3 square plus 3 square. So, this is 3 common, I plus j plus k, and this is 3 root 3. So, 3 cancel. So, this is unit vector from P to Q. P to Q. So, look, coordinates are given. So, you can find PV of Q minus PV of P. So, find PQ, then PQ cap. So, divide PQ by its magnitude. Now, second one, find a vector. Find a vector in the direction of 2I minus 3j plus 6k that has magnitude 21. That has magnitude 21. So, R equals to, suppose, 2I minus 3j plus 6k. Now, this is R vector. So, we find R cap. So, what is R cap? 2I minus 3j plus 6k by 2 square plus minus 3 whole square plus 6 square. So, 2I minus 3j plus 6k by 36, 4, 49. So, this is 7. So, this is unit vector. Listen. We have to find a vector of magnitude 21. So, we first find unit vector. then required vector is 21 into unit vector, because it has magnitude 1. So our main aim is to find a vector of magnitude 21. So you first find unit vector, then multiply it with 21, scalar multiple. So vector of magnitude 21 equals to 21 into r cap. 21 into r cap. Vector of magnitude 21, obviously in the direction of this 21 r cap. So 21 scalar multiple of this 2i minus 3j plus 6k. So 3 into 2i minus 3j plus 6k. So this is a required vector of magnitude 21. So these are all board's problem and very simple problem. Look, 2 marks problem only, 1 to 2 marks. Then see, find a vector of magnitude 5 and parallel to the resultant of alpha and beta in the direction of parallel to the resultant of alpha and beta. So alpha is given. So what is alpha? 2i plus 4j minus 5k, and this is beta, I plus 2j plus 3k. Now resultant of alpha and beta, resultant of alpha and beta, you know this is alpha plus beta. So alpha and beta are two vectors, their resultant is alpha plus beta. So 3i plus 6j minus 2k. 3i plus 6j minus 2k. So find a vector of magnitude 5 and parallel to the resultant of this and this. So we calculate unit vector in the direction of resultant of alpha and beta. Unit vector in the direction of parallel to resultant of alpha and beta. So in the direction of alpha and beta and parallel to alpha and beta, and parallel unit vector in the direction of resultant of alpha and beta, parallel to or in the direction of resultant of alpha and beta, same. So you are getting unit vector. Suppose this one is n cap. So 3i plus 6j minus 2k by 3 square plus 6 square minus 2 plus minus 2 whole square. So this is 3i plus 6j minus 2k by 7. And what is the magnitude? Magnitude is 5. So what is required vector? So required vector is equals to 5 into n cap. Magnitude of 5, unit vector into 5. So 5 by 7, 3i plus 6j minus 2k. Next, problem number D. So all are same type and very simple also. Look, the adjacent sides of a parallelogram are represented by this. Find unit vector parallel to diagonals. So look, this is OA. OACB is a parallelogram. OACB is a parallelogram. OACB is a parallelogram. OA is alpha vector. This is the adjacent sides 2i plus 4j minus 5k. And another is I plus 2j plus 3k. Now, these are two adjacent sides. Now, OC is diagonal. So, from definition of equal vector, so OB equals to OC, this equals to beta, and OA equals to BC equals to alpha. Now, what is diagonal OC vector? OC vector from figure OA plus OC, OA plus AC. OC is OA plus AC. So, OA plus AC. So, 2i plus I, 3i. So, what is OA? This is alpha plus beta. So, 2i plus I. So, this is 3i. 4j plus 2j. This is 6j. Minus 5k plus 3k. This is minus 2k. Minus 2k. So, this is resultant. So, unit vector. So, OC cap equals to 3i plus 6j minus 2k by root over 3 square plus 6 square plus minus 2 whole square equals to 3i plus 6j minus 2k by 7 by 7. So, this is unit vector along diagonal OC. Now, second diagonal, it may be BA or AB as you please. So, suppose AB. So, what is AB vector? PV of B minus PV of A. So, this is AB vector. PV of B, AB vector, PV of B. We consider O as origin. So, OB minus OA. O as origin. PV of B is OB. OB minus OA. So, beta minus alpha. So, beta minus alpha. So, this one is beta. I plus 2j plus 3k. So, this is beta. And this one is alpha. So, I minus 2i. So, this is minus I. 2j plus 2j minus 4j. So, this is minus 2j. 3k minus. So, this is 8k. So, listen again. I minus 2i. This is minus I. 2j minus. So, minus 2j. 3k minus minus plus. So, this is AB vector. So, diagonal AB cap, unit vector, minus I, minus 2j, plus 8k, by root over 1 square, plus minus 2 whole square, plus 64. So, minus I, minus 2j, plus 8k, by 64, plus 4, 68, 69. 69. So these are most important problems and basic problems. So problem number 5. Find all vectors in xy plane. Find all unit vectors in xy plane. So xy plane only it is in plane x-axis and y-axis. This is I cap, this is j cap. If P is a point x comma y, P is a point x comma y, then you know OP equals to xi plus yj. So what is OP cap? Xi plus yj by root over x square plus y square. So this is unit vector in xy plane. Z is not present because it is in xy plane. Now listen again. So look, this is a circle. This is OA. Unit circle radius 1. So suppose P is a point. And this angle is theta. So OP is 1. OP is equal to 1. Magnitude of OP equals to 1. So OP vector equals to, look, OM vector plus MP vector. What is magnitude of OM? OM by OP equals to cos theta. So magnitude of OM equals to cos theta. Since magnitude of OP equals to 1. So this is cos theta into I cap. Magnitude of OM is cos theta and unit vector in this direction is I cap. And here it is j cap. So similarly, if you calculate MP, this will be sin theta. Sin theta into j cap. So what is OP cap? OP cap equals to cos theta into I cap sin theta into j cap by root over cos square theta plus sin square theta. This is 1. So here restriction on theta is 0 to 2 pi. 0 to 2 pi. 0 to 2 pi. So you can write also answer in this form. So these are basic problems. Actually problems of unit vector. Now we consider some more simple problem. So 2a. So that the vectors these and these are unlike. Unlike vectors. So we know unlike vectors. They have opposite direction. They have opposite direction. So a vector equals to problem number 1 3i plus 2j minus 4k. Now what is b? Minus 6i minus 4j plus 8k. So if we take minus 2 common, so this is 3i plus 2j minus 4k. So look, we are taking minus 2 common because if we take minus 2 common, we get a. So this is minus 2 into a vector. So b equals to minus 2a vector. So a and b are parallel. And this negative sign represents that They are in opposite direction. So this is A and this is, suppose, minus 2A. This one A and this one is minus 2A. Suppose this is AB, and this one this is AB, and this one opposite direction, double of it. Suppose this is CD. So here A and B are unlike. A and B are unlike. So B equals to minus 2A. This negative sign indicates that A and B are opposite side, opposite direction. So therefore A and B are unlike because their directions are opposite. So if it is in this direction, second one is opposite to it. Now problem number B. For what value of P, the vectors this and this are parallel. So two vectors are given. This is 3i plus 2j plus 9k, and B is I minus 2pj plus 3k. A and B, two vectors. We know that two vectors A and B are collinear or parallel if A equals to scalar multiple of any vector can be expressed as a scalar multiple of other. So 3i plus 2j plus 9k equals to lambda into I minus 2pj plus 3k. So equating components of ijk, what we are getting? Components of I. So 3 equals to lambda. 3 equals to lambda. So 2 equals to minus 2p lambda. And 9 equals to 3 lambda. So here also lambda equals to 3. Here also lambda equals to 3. So put value of lambda. 2 equals to minus 2p lambda. So 1 equals to minus p into lambda. So what is lambda? Lambda is 3. So what is p? P equals to minus 1 by 3. So if two vectors are parallel, find p. P equals to minus 1 by 3. So basic problems. We are considering only basic problems. Now problem number C. For what value of x, y, z, this and this are equal. These two vectors are equal. So here xi plus 2j plus lambda k equals to 2i plus yj plus k. So they are equal. So from definition of equal vector, so equating components of ijk. So what is x? X equals to 2. 2 equals to y. 2j, y. And what is z? Z equals to 1. So A equals to B if corresponding components are equal. Next, problem number D. This is most important problem, this one. Using vector method, prove that the points A, B, C are collinear. So, coordinates are given. So, AB vector equals to, PV of B minus PV of A. So, what is PV of B? 3i minus 5j plus k. And PV of A 2i minus j minus 3k. So if we subtract, this is I minus 5j, this is plus j, minus 4j plus 4k, k plus 3k. So this is AB vector. So AB vector. Then you calculate AC vector or BC as you please. AC vector, PV of C minus PV of A. So what is PV of C? This coordinate, minus I minus 11j plus 9k minus 2i minus j minus 3k. So minus I plus 2i. So this is I. This is 11j plus j. So 11j plus j, so minus 10j. So 9k plus 3k, this is 12k. This is 12k. 9k plus 3k is 12k. So 12k, this is 12k. So AB and AC. So AB is not scalar multiple of AC. So we see the data again. Now listen again. So prove that the points 2 minus 1, this is plus 3. It will be plus 3, not minus. B and C are collinear. So AB vector equals to PV of B minus PV of A. So PV of B, this is okay. Now we have corrected it. So this is 2i minus j plus 3k plus 3k. So this will be plus. So 3i minus 2i plus I minus 4j, and this will be k minus 3k. So this is minus 2k. Now PV of C, I, this is 11. This one is 11. So this is plus 11. Minus 1. So plus 11i plus I plus 11j plus 9k. And PV of A. PV of A is 2i minus j. This one is plus 3k. So we have corrected it. So finally we are getting minus 3i minus minus 3i, and this one is 11j plus j plus 12j, 9k minus 3k, this is 6k. Now if we take minus 3 common, so I minus 4j minus 2k. So AC vector equals to minus 3 into AB vector. So lambda into AB vector. So AB and AC are parallel. AB and AC are parallel. So scalar multiple, but the point A is common. The point A is common. Therefore, ABC are collinear. ABC are collinear. Or you can directly say AC can be represented as scalar multiple of this. So they are collinear. Parallel and collinear vectors are same. Now you complete problem number E. 3 sides are given. You have to prove that it is They represent sides of right angle triangle. So, three sides are given, A, B, C. So, suppose this is AB. So, you calculate mod AB. So, what is mod AB? 2 square plus minus 1 square plus 1 square. So, root 6. What is mod? If we consider this as BC. So, what is mod BC? So, 3 square plus 7 square plus 1 square. So, 49, 50, 59, root over 59. If you consider this as CA, so mod CA equals to 25 plus 36 plus 4. So, this is 65. So, what we are getting? CA square, mod CA square equals to mod BC square plus mod AB square. So, this is 65, this is 59 plus 6, 65. So, CA is hypotenuse. So, angle B equals to 90 degree. So, it represents a right angle triangle. So, very simple problem. So, today through this video, I have discussed how to find unit vector, then collinear vector, equal vector, opposite vector. So, in next class, I will also discuss the basic concept, basic concept of board problem. Thank you for today.